Soul of brothers and sisters, good morning to all. Today's session is continuations of isomerism. Last class we are discussed about nomenclature of amines, IPAC rule for polyfunctional group, representation of configuration of organic molecule in 3D and 2D structure, then isomerism. Isomerism classified into two types. First one is a structural isomerism, another one is a stereoisomerism. Structural isomerism we are classified into different types. First one is chain isomerism, positional isomerism, functional isomerism, metamerism, tautomerism, ring chain isomerism and isotonic isomerism. Now we are discussing about metamerism. What is the definition for metamerism? For example, for first compound, totally common carbons are 1, 2, 3, 4, C4. Common hydrogen are the 3, 5, 10 hydrogen. Common oxygen, 1 oxygen. Second common, 1, 2, 3, 4, 4 carbon, common hydrogen, 5 hydrogen, here also 5 hydrogen, oxygen, 1 oxygen. Here for that common, 1, 2, 3, 4 carbon, common hydrogen is a 10 hydrogen, 3 plus 3, 6, 9, 10 hydrogen, common oxygen, 1 oxygen. What is the definition for metamerism? Metamerism arises due to same molecular formula, same functional group, but number of carbon atoms or alkyl group on both sides by the functional group differ. This known as metamerism. This common, first common, these are ether commons. How to give the number from which side? Functional group attached to the first carbon, give the least number. 1, 2, 3. 1 methoxy propane. Second one, this side is a ethyl group, it is also ethyl group. It's a common name for ether, dialkyl ether. IPAC name alkoxyalkane. Here both sides same number of carbon atom. Any one of the carbon atom acts as a parent one, another one is a substituent. Ethoxyethane. For that compound, this side 1 carbon, from this side 3 carbon. Functional group attached to the first carbon give the least number. But one more thing, first select the longest carbon atom. Longest carbon atom 1, 2, 3. 1, 2, 3. In the second portion there is a substituent, that is a functional group. So 2-methoxy propane. Another one, these are first examples. Another examples. This one for the condensed form, this one for the bond line structure. Both are same functional group. Here common carbon 1, 2, 3, 4, 5, 6 carbon. Here 1, 2, 3, 4, 5, 6 carbon. Common oxygen, here 1 oxygen, here 1 oxygen. This one example for metamerism. Another one. CH3, NH, CH2, CH2, CH3. CH3, NH, CH2, CH3, CH3. These two are example for another example for metamerism. This one nitrogen containing the one hydrogen and two alkyl group. This one best example for secondary amine. How to give the number? 1, 2, 3. Long chain acts as a word root. So first position attached with the functional group N methyl. 20 common carbon, 3 carbon, propane, 1 amine. Here 1, 2, 3. N methyl, propane, 2 amine because of functional group present in the second carbon atom. CH3, CH2, NH, CH2, CH3. It is also example for secondary amine. From this side 2 carbon, from this side is a 2 carbon. How to give the numbering? Is a 1, 2. Any one of the carbon atoms act as a word root. So N ethyl, ethanamine. This one another examples. CH3, C double bond O, CH2, CH2, CH3. CH3, double bond O, CH, CH3, CH3. This one example for keto group, best example for metamerism. So how to give the numbering? From which carbon? From least side. 1, 2, 3, 4, 5. Totally how many carbon? 5 carbon. 5 carbon pentane. So pentanone, 2 pentanone. This one 1, 2, 3, 4. So third portion there is a substituent 3 methyl. Remaining how many carbon atom? 4 carbon atom. 2 butanone. In that common, totally how many carbon atom? 1, 2, 3, 4, 5. In that component 1, 2, 3, 4, 5. Same number of carbon atom, same number of hydrogen atom, same number of oxygen atom. This example for the another example for the metamerism. It is also what example for metamerism. These are substituent present in the meta position, substituent present in the para position. These are the example for the another one example for metamerism. This one, another one example for metamerism. All are example for metamerism. This type of common may be asked the need. Next, isomerism, tautomerism. Or dynamic isomerism. Or or ketoenol tautomerism. All are same. What is the meaning for tautomerism? Tauto means turn bond. For example, carbon valency 4, hydrogen valency 1, oxygen valency 2, nitrogen valency 3. Here carbon valency 4. This one best example for nitro compounds. Primary nitro compounds. This undergo tautomerism. Tautomerism nothing but migration of alpha hydrogen. Functional group nearest to carbon alpha. This hydrogen migrate towards the bond. CH2 double bond. N positive charge, oxygen negative charge, OH. This hydrogen, acetic hydrogen, so AC form or isonitro form. What is the definition for tautomerism? A single compound exists two readily interconvertible structure due to 1,3 migration of alpha hydrogen. This is known as tautomerism. What migration? That is a 1,3 migration of alpha hydrogen atom. Here one more important point is primary nitro compound and secondary nitro compound only form the tautomerism. Tertiary nitro compound does not form the tautomerism. For example, CH3, C, CH3, CH3, NO2. Functional group attached carbon carry no hydrogen. This compound does not undergo tautomerism. Clear? Maybe ask the one more question. Another one. There are different structure for tautomerism. Totally is what is several type of tautomerism. Among several type, there are two types very important. First one is diode system. Another one is triad system. What is the meaning for diode system? For example, what is the valency of hydrogen? Hydrogen valency 1. Carbon valency 4. 1, 2, 3, 4. Nitrogen valency 3. 1, 2, 3. What is the definition for diode system? Hydrogen atom oscillate between polyvalent atoms. Polyvalent atom or carbon nitrogen atom. Carbon which carrying the negative charge, nitrogen which carrying the positive charge. What is the definition for diode system? Hydrogen atom oscillate between polyvalent compounds or carbon nitrogen atom. This one example for diode system. Another one triad system. This one best example for dimethyl ketone or acetone. This one keto form, this one enol form. What is the definition for triad system? Hydrogen atom move from first carbon to third atom in a molecule or compound. This is known as triad system. What is that? Hydrogen atom move from first atom to third atom in a molecule. This is known as a triad system due to 1,3 migration of alpha hydrogen. This one is a keto form, this one is a enol form. Another one more structure. Cyclohexane undergo keto enol form. This bond is shifted here, bond here similar. These all are example for keto enol form structure. What is the order for enol content? First order aldehyde, ketone, keto, aldehyde, diketone. Increasing order aldehyde, for simplest aldehyde which containing the alpha hydrogen, that is acetaldehyde. Another compound keto aldehyde, diketone. This type of question may be asked the need. Which of the following compound exists highest percentage of enol form? This compound diketone is what undergo highest percentage of enol form. Next, differentiate between resonance and tautomerism. Resonance, for example, phenol, this is known as a resonance structure for phenol. What is the definition of resonance structure? The phenomenon in which one or more structure can be writing in the compounds, but a fixed number of position of atom and nucleus. For example, there is any aldehyde or ketone. For example, aldehyde, This one example for tautomerism. What is the major difference between resonance structure and tautomerism? In the resonance structure, position of atoms and the nucleus are fixed, while in the tautomerism, simultaneous migration of hydrogen and bi-bond takes place, 1,3 migration of alpha hydrogen. This is point number 1. Point number 2. Tautomerism form the different functional group, keto and enol form, but resonance structure formed by the same functional group. This is point number 2. Point number 3. Resonance structure can be obtained by the delocalization of bi-bond or non-bonding electron, or both are involving. While in tautomerism, structure obtained by the delocalization of sigma bond or bi-bond. These two are major difference between resonance structure and tautomerism. Another one, ring chain isomerism. What is the definition for ring chain isomerism? Compound having same molecular formula but possessing open chain and cyclic structure are known as ring chain isomer. The phenomenon known as ring chain isomerism. For examples, CH3, CH, double bond, CH2. This is an open structure, this one is a closed structure. Here, totally how many number of carbon atom? 1, 2, 3. 3 carbon, so C3. How many number of hydrogen atom? 3, 1, 4, this is 6. 6 hydrogen atom. This structure, carbon. Totally how many number of carbon? 3 number of carbon. This one best example for alicyclic compounds. What is the valence of carbon? 1, 2, remaining 2. CH2, CH2. This one example for propene. Because of carbon-carbon double bond. Best example for unsaturated compound. This name, cyclopropane. This one best example for alicyclic compounds. Another one structure, CH3, CH2, CH, double bond, CH2. Another one example for ring chain isomerism. Here totally how many carbon atom? 1, 2, 3, 4. C4. How many hydrogen? 5, 7. Here 2, 8 hydrogen. Here 1, 2, 3, 4. Each carbon carrying 2 hydrogen, totally 8 hydrogen. For in that component, there is a carbon 1, 2, 3, 4. 4 carbon, how many hydrogen? 8 hydrogen. Here 2, here 2, here 1, 5. 5 plus 3, 8 hydrogen. This one another example for ring chain isomerism. What is the name of this compound? Functional group attached to the first carbon, give the list number 1, 2, 3, 4. What is the name? 1, butene. This name, totally how many carbon atom? 1, 2, 3, 4. Butane. This one, methyl cyclopropane. What is the definition of ring chain isomerism? Compound having same molecular formula but possessing open chain or cyclic structure are known as ring chain isomer. The phenomenon known as ring chain isomerism. Last isomerism, isotonic isomerism. Isomerism arises due to presence of different isotopes of elements are possible. This is known as isotonic isomerism. For example, CH4 and CH4. Carbon is what? Exhibit plus 2 atomic mass. This carbon exhibit 14 atomic mass. This is example number 1. Example 2, H2O and T2O. Third example, CH2O, CH2O. Oxygen exhibit atom number 6, this atom number 8. This is known as for example for isotonic isomerism. Isotonic isomerism is due to presence of different isotopes elements are present. Another one is last one important topic is cyclic ether. First one, what is the definition for ether? Oxygen atom linked to the both side by the is a saturated or unsaturated aromatic compounds. This is known as example for cyclic ether. This is a totally common carbon atom 1, 2. So common name ethylene oxide. IPAC name here totally common carbon atom 2 carbon atom. So 1, 2 epoxy ethane. Another one, so totally common carbon atom 1, 2, 3 carbon atom. Here 2 carbon atom ethylene oxide, 3 carbon atom propylene oxide. What is IPAC name? The IPAC name here 1, 3 epoxy propane. Another one, this is a second one, another one is a third one. 1, 2, 3, 4. Totally common carbon atom 4 carbon. This name propylene oxide. IPAC name 1, 4 epoxy. Totally common carbon atom 1, 2, 3, 4 is a butane. One, 2, 3, 4, 5. Totally common carbon atom 5 carbon atom. So pentylene oxide. IPAC name 1, 5 epoxy 1, 2, 3, 4, 5. Yes, sir? Pentane. These all are example for cyclic ether. Ether already completed. Let us recap the is a fundamental of organic chemistry. First is a definition of organic chemistry. Next, classification of organic chemistry, that is organic compound based on the structure or functional group. Next one, characteristics of organic compound, then functional groups. Totally is what 30 functional groups are there. Among 30 functional group, 12 functional group are important based on the need. First one, alkyl halide, alcohol, ether, aldehyde, ketone, carboxylic acid, acid halide, acid anhydride, amide, ester. Last one is nitro compound and amino compounds. There are 12 functional groups important based on the need. Another one is isomerism. What is the definition for isomerism? Isomerism arises due to same molecular formula, same functional group, but a different physical and chemical property. This is known as a definition for isomerism. Isomerism can be classified in different types. Structural isomerism, another one is stereoisomerism. What are the structural isomerism? Chain isomerism, position isomerism, functional isomerism, metamerism, tautomerism, ring chain isomerism, and isotonic isomerism. Here, organic compound is a volatile nature. How to practice the compounds regularly? Good luck.